In this video, we're going to talk about how we can convert two bases that have a common base back and forth between them. Now, we already learned last week that you can rewrite the value in base 10 and then convert it into the desired base. However, there are some times where the two numbers will have a base in common, such as they are both connected via base 2 or base 3. Those are the most common ones I have seen. So when this occurs, what we can do is we can rewrite each digit as it would be in the new base. So if you think about that, my example here is I have 6 base 8. Well, if I think about how would I write an 8 in base 2, in base 2, I have my 1's place, my 2 place, and my 4 place. So if I wanted to represent 6 in base 2, there is 1 4, 1 2, and 0 ones, because 4 plus 2 would give me 6. So if we take that idea and apply that to this next problem, then when we are in base 9 and we want to convert into base 3, we can say that a single digit in base 9 is going to be converted into 2 digits in base 3. So what you want to do for this is you want to essentially say, okay, this is a 4-digit number, so I'm going to have 4 sections of 2 spaces each. So what we want to do is just go through and convert each number one at a time. So my 6 in base 3 would be 2 3s and no 1s. My 4 in base 3 is 1 3 1 1. 7 is 2 3s and a 1, and 8 would be 2 3s and a 2. And so essentially what we just did, rather than having to go from base 9 into base 10 back to base 3, or rewriting, expanding, and so on, we can just say that our final answer is 2 0, 1 1, 2 1, 2 2 in base 3. And that is a lot faster than some of the other methods that we've used. Now if we apply this to the next problem, here we're trying to go from base 8 into base 2. So again, in base 8, we have a 1's place, and in base 2, we have a 1's, a 2's, and a 4's. So now, in this case, every digit is going to be represented with 3 digits. And since this is a 4-digit number, I'll have 3 digits for the first, the second, the third, and the fourth. And again, let's think about these as being divided up like that. I find it much easier to divide them visually, so I'm just focusing on one number at a time. All right, so I'm going to have you pause the video and then try to fill in these numbers, and then we'll check back. All right, so to represent a 7, that's going to give me a 4, a 2, and a 1. And fun fact, when you're trying to represent the number that is the greatest allowable digit in any base, it'll always be all 1's. And then my 6 is going to be a 4 and a 2 and 0, and then I'll have only 1, 2, the rest are 0's, and then my 1, I just have 1 over here, and the rest are 0's. So my final answer, 1, 2, 3, 4, 5 1's, 0, 0, 1, 0, 0, 0, 1. And that will be my final answer in base 2. All right, now if we are going the other direction, similar idea, except we have to think of it in reverse. So in base 3, I have a 1 and a 3, and I'm going to convert that into just 1 digit for base 9. So now what we want to do is visually think about each of these numbers as groups of 2's. And when we do these as groups of 2's, we have to start from the right and work our way in. Okay, that's very important because it's possible that the leading digit might be a 0. So that's why we always start from the right. So I could say, for example, right here, let me just circle these, that those 2 are going to be a digit and these 2 are going to be a digit. And I can just go through and group them 2 digits at a time. And then here, yep, we actually do see that where our last digit is just a singular digit, that would be like having a 0 in the front. And so since I have 5 pairs of digits, I'm going to have 5 answers or 5 values. And then now I just go ahead and ask myself, okay, well, what number do these 2 values represent? and then I can convert that into base 9. So in this case, if I think about the 0, 2, that would just be the number 2. And if I think about the number 2, 0, well, that would be 6 right here, and this is a 1. And when I see 2, 1, oh my goodness, when I see 2, 1, that's going to be 6 plus 1 gives me 7. And then here, this would just be 2. So my final answer in base 9 is 27162. All right. Now, for this last one here, this is similar to the problem that we saw on our contest last week, and it was a beast when we worked through it. So I want to show you how we could have done this problem in a simpler way. So first, we are going to go into base 2, and then once we're in base 2, we will regroup to be in base 4. All right, so if I'm going into base 2, just like we saw a minute ago, my base 2 had 1 digit going into 3. So that's our first step. So here I have 4 digits, so I'm going to have 4 groups of 3, and I can separate them like this. And then now I represent each number in base 2. So my 6 is going to be 1, 1, 0. And then next, my 4 is 1, 0, 0. My 2 is 0, 1, 0. And my 3 is 0, 1, 1. Now, since I'm going from base 2 into base 4, in base 2, I have 3 digits equal an 8. Or actually, hold on, let me think about this. Let's explain this a different way. Think of it this way, that in base 2, 2 digits correspond with 1 digit in base 4. So now what I'm going to do is I'm going to go ahead and circle these again, starting from the right in pairs. So there's one pair, there's another pair, and so forth. We just keep working our way down. And since I have 6 pairs, that means that my final answer will have 6 digits. And so now I can go ahead and represent these, remembering that this is the 1's place and this is the 2's place. So 2 plus 1 gives me 3, 0, 1, 0, 1. And then this here is 2 plus 1, which again gives me 3. And that will be my final answer in base 4. So hopefully these shortcuts were helpful, and that is it for today.